The company offers a wide array of products made of thermoplastics, and its core business activity is the manufacture of wastewater treatment devices. Since we are using around 200 tons of thermoplastic per year, we need a new technology that would help us save on raw material and reduce the volume of the device while maintaining or improving its efficiency. We wanted to keep up with the technological development and introduce innovative processes into our production, but it was impossible to find big technological centers that would help us in Croatia. So we decided to apply for the KET4CleanProduction project. The KET platform allowed us to connect with 2 technological centers abroad who helped us introduce the moving bed Biofilm reactor technology into our production process.
Modeling of wastewater treatment processes was our expertise used in KET4CP project. Modeling is widely used in this field and is very useful since the wastewater treatment processes are quite complex. Within the KET4CP project, modeling was used to assess how the wastewater treatment devices produced by Bor-plastika would change if MBBR technology is used, which means that small biomass plastic carriers are introduced into their devices for wastewater treatment. With the models, we have predicted and compared with conventional activated sludge process different parameters, for example, the quality of the effluent, the volumes of the reactors, the sludge production, the air supply, and so on.
The uniqueness of our approach was the composition of the materials used to fabricate the biocarrier. The surface of the biocarrier, which can be greatly influenced by its material composition, is a very important factor for the performance of the MBBR. By replacing part of the biocarrier composition with nanocellulose instead of polymer, this approach enables not only a more ecological friendly solution by reducing the use of petroleum-based materials, but also their recyclability due to enhancement of the reinforcement of the carrier. At INL, we fabricate and characterize nanocellulose-based composites to enhance biofilm processes. These hybrid composites would be able to give a solution to the dependency of petroleum plastics in the fabrication of the MBBR carriers, which will allow a more eco-friendly and recyclable fabrication of these components involved on the MBBR technology. By introducing MBBR technology, Bor-plastika would save on raw materials, water, energy consumption, as it will reduce the volume of the site testing, while the efficiency of the device would remain the same or better than before. In addition, the thermoplastic reinforcement with nanocellulose will not only address environmental issues, but it also will improve the mechanical properties and the recyclability of the carriers.
We wish to have an opportunity to continue the work with more experiments in larger reactors. For the modeling, this would bring new data to validate and to improve the models, as well as to optimize the process reactors.
It was very interesting to cooperate with the SME and with the TCs. And actually we are still working with them regarding the simulation process to evaluate the developed MBBR process performance.
The Technology Center's employees were always available and ready to answer all our questions about the project implementation. Since we are currently cooperating with them on other projects, I would say that we are more than happy with them.